So from problem set C in 11.5, you are assigned number 21. A square formed by joining the midpoints of alternate sides of a regular octagon. The side of the octagon is 10. Find the area of the square. Now it's going to be a little helpful to take a closer look at this shape. The first thing I'm going to do is draw in the diagonals of the square, hoping that might show me something. Then what I can kind of see is I almost have 4 little squares forming. And I know that's going to be a right angle. This side is 10. That's an isosceles right triangle with a hypotenuse of 10, which makes the leg 5 root 2. We already know this whole side is 10. And then if we were to continue the same square on the other side, we know that this also would be 5 root 2, which makes then the diagonal of the square. Remember, the diagonals of a square are congruent, and then their sum is 10 plus 10 root 2. Now, I'm going to take another look at the properties of quads. We haven't seen those in a while. So here I pulled up the family tree. We're looking for the area of a square, and we always think of that as being the side squared. But we could just as easily use the area for a rhombus, or the area for a kite, or a rectangle, or parallelogram, because the square is all of those things as well. So since we know the length of each of those diagonals, the area of the kite is 1/2 of one diagonal times the other. So 1/2 of one diagonal gives me okay, so 5 times 10 gives me 50, and then root 2 times root 2 gives me 2. So that's going to be 100 plus 50, and then I have these two that can combine as well. And there's my area of the square. In part B of this problem, we're asked to find the area of the shaded region. Well, the area of the shaded region is going to be equal to the area of the octagon minus the area of the square. So the area of the octagon is going to be 1/2 the apothem times the perimeter, and we have the area of the square from part A. The apothem is going to be 1/2 of the length of the diagonal, which is going to be 5 plus 5 square root 2. And then the perimeter, we have 8 sides, and each of those sides is 10. So 1/2 of 80 is 40 times 5 plus 5 square root 2. Distribute. Oops, forgot a 0. Don't forget to distribute the negative. Then the root 2's combine, the whole numbers combine, and we should get 50 plus 100 square root 2. In problem number 23, you're given an equilateral triangle with an inscribed square. That means that the vertices of the square fall on the triangle itself. We're asked to find the area of the shaded region. So the area of the shaded region is going to be equal to the area of the equilateral triangle minus the area of the square. The area of the equilateral triangle is the side squared square root of 3 divided by 4. So that's 12 times the square root of 3 divided by 4. And we can reduce. So we have 36 square root of 3. That's not the tricky part. The tricky part is figuring out the area of the square because we don't know the length of the side. So let's take a closer look at that. We know that the equilateral triangle, all of the angles equal 180 degrees, and we know that all of these angles are congruent. So each one has to be 60. If this is 60, and the square has a right angle, the supplement of that is a right angle, that's going to be 30. So then we have a 30, 60, 90, and the ratio of those sides is x, x square root 3, and 2x. Let me, for grins and giggles, call the side of the square S. That's across from 60. The equation that I need to solve for is right there. If x square root 3 equals S, then x is equal to S divided by the square root of 3. And we want to rationalize that denominator. We never leave radicals in the basement. We don't want them staging a coup. So then we have S times the square root of 3 divided by 3 for the side opposite 30, which is right here. And this part is also congruent. This side right here, this length, is the same here as it is there. Use 3 tick marks. And we know that the whole thing is 12. So if I took 12 minus 2 of those, I would get the length of the side. So I can say that 12 is equal to the side plus those, I'll just say 2 parts. So if I want to solve for one part, I would take 12 minus the side and then divide by 2. That should be equal to that. So now I need to figure out the length of the side of this square in terms of numbers. So I have 2 expressions, and I can set them equal to each other. Means extremes product theorem allows me to say that these are equal. That's cross multiplication. And then I want S on one side. So I'm going to add the 3s to both sides. And then I'm going to factor out that s. And that leaves me with 2 root 3 plus 3. And then I'm going to divide both sides by that other term. So 36 divided by 2 root 3 plus 3 is equal to the side of the square. Now that we know the length of the side, we can go ahead and substitute that in to our equation. And this is going to test your algebra skills a little bit. So 36 squared is 1296. Then the video maker stopped on me, so I'm going to try to walk you through what I did. We have to square the side, which means we have to FOIL the binomial that's in the denominator. So 2 root 3 times 2 root 3 gives me 12, because 4 times 3 is 12. And then 2 root 3 times 3 is 6 root 3. And then the last term times the first term is also 6 root 3. Finally, the last term times the last term is 9. We can combine the whole numbers to get 21 and combine the 6 root 3's to get 12 root 3. Now, what we need to do next is called rationalizing the denominator. We just haven't done that with a binomial. Now we will. To rationalize the denominator with a binomial, you want the first and last terms to be the same, just the signs to be different, because when you FOIL it through, your outer term is going to be negative 12 times 21 times root 3. Your inner term is going to be a positive 12 times 21 times root 3. They'll cancel each other out. You'll be left with just whole numbers in the denominator. So 21 times 21 is 441. And then 12 root 3 times 12 root 3 is 144 times 3, or 432. Still bringing this down. So now in my numerator, I have 27216 minus 15552 root 3, and that's all over 9. So let's take a closer look at these numbers in the numerator and see if they're divisible by 9. 2 plus 7 plus 2 plus 1 plus 6 is 18. 1 plus 8 is 9. That means that whole number is divisible by 9. So that works out to be 3024. And now I'm going to distribute the negatives through. So a negative times a negative is a positive. When I look, at 1 plus 5 plus 5 plus 5 plus 2, I get 15, 16, 17, 18, also divisible by 9. That works out to be 1728 square root of 3. Now I'm going to go back up here and fetch that 36 root 3. So this term and this term will combine. 36 and 28 is 64. So now I have 1764 square root of 3 minus 3024. That, gentlemen, is the area of the shaded region. And I'm putting this to bed. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.